On question number 11, we are given this open top cylinder and we are told that the volume of the cylinder is 1500 and we are asked to show that the surface area is given by this formula here. Now for a question like this, we could either start with the formula for the volume or the surface area. Since we are asked to show that the surface area is something, we'll start with that. Now the surface area of a cylinder is given by, so we'll say A is equal to, now this is open top, but we still do have the circle that's on the bottom. That will be given by pi r squared. Then the curved surface area of the cylinder is given by 2 pi r h. Now the formula that we are asked to show that the surface area is, now this one clearly does not have the h term. So we do have the pi r squared, which we have here, but we need to somehow show that this bit, show some way to get rid of this h term. So at this point, what you would do is start with the formula for the volume. So we are given that the volume is 1500. Now the volume of a cylinder is given by pi r squared h, and we are told that this is equal to 1500. Now what we could do here is we could make h the subject. So we'll just get rid of the v here. So I'm going to say h is equal to 1500 divided by pi r squared. That's just dividing both sides by this pi r squared term here. What we can then do is substitute that. So substitute h equals this one into the formula for the surface area. So this formula now becomes pi r squared plus 2 pi r, and then instead of h, I'm going to write 1500 divided by pi r squared. Now at this point you could either expand the brackets first and then simplify. I think what I'm going to do is I can cancel off one of the r terms, and then I can also cancel the pi term. So if we expand the brackets now, what we get is that a is equal to pi r squared plus, so on the numerator we are just going to have, so you can think of this as 2 over 1. 2 times 1500 gives us 3000 divided by, we then have on the denominator we just have the r term. Okay, so that's part A done. Okay, on part B of this question, we are then told to find the value of r for which the surface area has a stationary value. Right, so which means we'll need to differentiate A, make it equal to 0 and solve it to find a stationary point. So the first thing we need to do is to rewrite this into a form that we can differentiate. So instead of writing it as 3000 over r, we'll need to write this as pi r squared plus 3000 r to the power minus 1. Right, we can then differentiate this, make it equal to 0, and see if we can solve that. So if we differentiate this one, so I'm going to say that's dA over dr is equal to, so differentiating pi r squared with respect to r is going to be 2 pi r. Then differentiating this, if you bring the power to the front, we're going to have minus 3000 r to the power minus 2. So that's the differentiation step done. So we need to make this equal to 0 and then find a way to solve this. So if I then say that this is equal to 0, what I'll do is I'm going to take this term to the right hand side just to make that positive. Okay, so this should be 3000 here, not 300. Right, so if I take that to the right hand side, I should have 3000 r to the power minus 2. But instead of r to the power minus 2, what I'm going to do is to rewrite that back as a fraction as r squared. And on the left hand side, I'm just going to have 2 pi r. So here what we're trying to do is make r the subject. So what we'll need to do here is multiply r squared onto this side. So that will make that r cubed. And this 2 pi term, I'm going to divide it onto the right hand side. So I'm going to say this is 3000 divided by 2 pi. Right, then to find r, we just need to take the cube root. So you could simplify this a bit and write this as 1500 over pi. But if you're just going to do this on the calculator, you could just simply say that this is 3000 divided by 2 pi and then take the cube root. So if you plug all this into a calculator, what you find is that r is equal to 7.82 centimeters to 3 SF. Then on part C of this question, we are asked to show that the value of R that we found, the 7.82, does indeed give us a minimum value for A. So in part B, we found a stationary point. We showed that when R equals 7.82, we get a stationary point. So now we need to verify that that point does indeed give us a minimum. And the way we do that is by finding the second derivative and then check the sign of the second derivative at that stationary point. So I've already got written here the first derivative which we found for part B. So if we differentiate this now, so the first bit will just become 2 pi, differentiating with respect to R. Then this part, when we differentiate, that's going to give us minus 2 times minus 3000 here will give us plus 6000 R to the power minus 3. Right, so all we need to do then is to substitute the value of R. So let's say when R is equal to 7.82, we want to check what is the value of d squared A over dr squared. So substituting this number in, so we have 2 pi plus 6000 times 7.82 to the power minus 3. Right, so even without calculating this number, we know this will be positive, but of course you type this into a calculator, see what number it gives you. And this is equal to 18.8. Right, so since the second derivative at our stationary point is greater than 0, we'd say that this implies that this is indeed a minimum. Part D then is just to find the actual surface area, the minimum surface area of the container. So we found that the stationary point is when R is equal to 7.82. So we just need to plug that value in. So I'll just do that on this side here. So this is part C. For part D, all we got to do is find the value of A when R is equal to 7.82. So we had the formula for A here, which was already given to us, which we showed here as well. So let me just copy that one down. So we know that the area is given by this formula. We just need to check the value of this when the radius is equal to 7.82. So the minimum area is going to be equal to pi times 7.82 squared plus 3000 divided by 7.82. So the area at that point is going to be, so again, if you do this on the calculator to 3SF, we get 576 centimeters squared.